Hi guys. On this first question, we want to find the probability that a randomly selected full carton of eggs weighs more than 850 grams. So if X represents the weight, I'm looking for a weight that is more than 850 grams. So to do a question like this, because we're using the normal distribution, we want to change this 850 into a z-score. So instead, we can think about this as the probability that z is greater than 850. There's our observation. Take away the mean of 840, and then divide by the standard deviation of 7.9. So we can approximate that z-score. That's 10 divided by 7.9. We'll call that z-score, we'll call it 1.27. So remember, what the shade norm command will do for us, it will give us a percentage. And we can interpret that percentage now as a probability. So working with z-scores, we've got a mean of 0. We've got a standard deviation of 1. We are interested in having a z-score above 1.27. So that 1.27 will be our lower boundary, and using the shade norm command, we want to include a relatively high upper boundary. The truth is 10, a z-score of 10 standard deviations above the mean is more than sufficient. So the first thing you want to do, if you press second y equals, you want to make sure all that your plots are off. So the next thing, you want to run the normal window program. So all that program does, it sets this window so that we can see our normal distribution. So I don't remember the last time that I cleared my drawing, so I'm just going to press second program, enter, enter, in order to clear my drawing. So here we go, second, variables, over to draw, press enter. My lower boundary is the 1.27. The upper boundary, will make it 10. You can make it higher than that if you want. We're using z-scores, so they have a mean of 0 and a standard deviation of 1. And this will give us our percentage, or in this case, our probability of 0.102. And then the rest of the question is just a matter of using that probability. So using this answer, what is the probability that a randomly selected full carton of grade A eggs will weigh less than 850 grams? Well, this is the probability of more than 850 grams. So to get less than 850 grams, we just need to take 1 minus the 0.102. And that will give us 0.898. And there's the end of that question. That's just the complement. The complement of more than 850 grams is less than 850 grams. So last, assuming that the weights of full cartons are independent of one another, we're going to use this answer right here to find the probability that at least one of 4 randomly selected full cartons will weigh at least 850 grams. So I want the probability that at least one of 4 weighs at least 850 grams. Well, we can think of that as 1 minus the probability that none of the 4 weighs at least 850 grams. But none of the 4 weighing at least 850 grams, that means that all of them weigh less than 850 grams. So by independence, I can recycle this probability down here. None of the 4 weighs at least 850 grams. All of them then have to weigh less than 850 grams, all 4 of them. By independence, there we go. 1 minus 0.898 to the power 4. Go back to the home screen. 1 minus 0.898 to the power 4. And we should be done. That probability is about 0.350. There we go.